Well, admittedly, the process isn't quite that fast in reality. But the automatic system works reliably. In this video I show the assembly and programming of my AT-Tiny Stepper motor control. In this example, for opening and closing a kitchen door. First I remove the defective gas pressure damper, which no longer reliably holds the heavy glass door open. Because of the special design, I would have had to replace it with a very expensive original damper from the manufacturer. Because I'm currently experimenting with my stepper motor control, I thought that the damper could also be replaced with a linear drive. To do this, I glued a pivot bearing with a lock to the stepper motor. This makes it easy to install and remove the motor. I mount a joint on the end of the spindle, which is then attached to the door. A small ball bearing in the joint ensures smooth movement. The joint of the linear unit is screwed to the door with a bolt. I attach the pivot bearing of the stepper motor to the cabinet wall with double-sided adhesive tape. Now connect the controller and carry out the first test. I explain the exact functionality of the individual buttons in the video, AT-Tiny 13 Stepper Motor Controller for Lathe. What is still missing is the programming of the distance and the speed at which the door should open and close. So that you can see the programming process better, I'll mount the breadboard prototype again. The buttons are a little further apart here. Programming is done quickly. Point 1. Change the power on state to 2. To do this, press the R and 2 buttons at the same time. The change is confirmed with the green LED. Point 2. Use the button 2 to go to the end point of the distance. Point 3. Save the distance in the EEPROM using the button 5, and reload it with the button 1. Point 4. Use the potentiometer to set the opening speed and save it. To do this, press the R and 3 buttons at the same time. The change is confirmed again with the green LED. Point 5. Load the saved distance from the EEPROM using the button 1. Point 6. Now set the speed for closing the door and save it. To do this, press the R and 5 buttons at the same time. Now all necessary values are stored in the EEPROM and programming is complete. The actual construction should of course be done with the sandwich board. This is more compact and can later be attached directly to the motor. Of course, the values still have to be programmed for the ATtiny used here. I will therefore show the 6 programming steps again in a quick run-through. First, select the power on state, 2, again. Use the button, 2, to move to the end point of the door. Save the distance into the EEPROM using button, 5, and reload it using button, 1. Now set the opening speed and save with the buttons, R, and 3. Load the saved distance from the EEPROM using the button, 1. Now set the closing speed and save with the buttons, R, and 5. That's it. The control panel can now be removed and the sensor button connected. The sensor now takes over the function of the repeat distance button, 3. Of course, you could also lay the cables more discreetly under the cabinet. But for quick installation, I first glue the sensor and the motor control in place with hot glue. Now that the installation is complete, the kitchen cabinet is ready for daily use. I think this is a nice feature that enhances the cupboard and the kitchen. That's why I'm considering whether I should convert the other glass doors as well. I show another example of the tiny motor control in the film, ATtiny Stepper Motor Feed for Lathe. So subscribe to the channel now and don't miss anything. Thanks for watching.